Okay, so when you have the exponential decay, it can start positive or it can start negative. Okay, so if it starts positive and it's decaying, it could be getting closer and closer to 0. Or it could start negative and get closer and closer to 0. Okay, so if you look at growth, it always ends up either going towards infinity or negative infinity. For decay, it always starts at infinity or negative infinity and gets closer and closer to a value. In this case, closer and closer to the x-axis, but it could be a different value just depending on your equation. Okay, so one thing that we're doing today is we're just going to look at the function and determine if it's growth or decay. So whenever you're given an equation, you have to pick out what the base value is. Remember that the base value is always attached to the exponent. So for each one of these, we're going to pick out the base value, and then we're going to say if it's exponential growth or decay. Okay, so for these ones, when you're doing them on your homework, these should go pretty quickly. You just have to identify what your base value is. So which one of these is my base? 2. So that's on the x. Okay, so is that growth or decay? It's growth. So don't let the negative confuse you. The negative has nothing to do with whether it's growth or decay. You can grow in a negative direction. Okay? And then for this one, what's your value of b? 5/4. Is that greater than 1 or in between 0 and 1? Greater than 1. Well, what do you mind grabbing the door? Yeah. There's fear in my eyes. Okay, and then your value of b for c is 3/4, and that is between 0 and 1. Okay, so yeah, if it is decay, there should be a fraction or a decimal. And those are the only cases that you're going to see. Can you guys think of a tricky case where it would be decay if you didn't see a fraction or a decimal? Remember the negative exponents make fractions? But I don't think you have any of those. That would be tricky. All right. So now we're gonna graph. Okay. So for some of the ones you have to graph, I labeled this to fit the book. If you're wondering why sometimes the examples are random like that, it's because I was trying to make them to fit the book. And sometimes it'll just say graph the function, and if it just says graph the function, then I just want you to graph and include a table with your points, but you can use your graphing calculator for that. Okay, so the problem's below and on your homework. Okay, other questions are going to ask you to graph and then find some key values. Okay, so you're going to have to be able to find the domain, range, y-intercept, asymptote, and end behavior. Okay, so you only have to identify those if the problem asks you to. Okay? All right, so for the first one, A is f of x equals 10 to the 3/4 to the x power. And then we're going to have a table. I guess technically I don't know because I haven't done it yet, but maybe you'll have maybe you have two parts to it. Yeah. So when you're doing this graph, I'm always going to if you have to do something like this. Yeah, I'm going to let you have a calculator for that. Okay. So you have 10 to the 3/4. Oh yeah, you'll for sure have a calculator because we're going to do some regression next week. You guys remember that? We have to find the R values. Okay, so if you have 10 to the 3/4 x and you graph it on your standard window, it looks like this. And you can see this is more of a softer curve here. If you adjust your window so you can see a little bit higher, sometimes that does help. You get a better picture of what's happening there. Okay, you can also extend your x values out. Okay, so to get a nice picture of what's happening here, we're probably going to have to extend our graph and we're going to have to do a scale. Okay, so I scaled down there for the last ones. So look how large these numbers are. So those are really, really big. So let's see what's happening closer to 0. Okay, so at -5 I have -42, -4 I have 31.6. Okay, and then here I can look and see if I keep going, I'm getting closer and closer to 0. Okay, I'm starting to get the exponential, the scientific notation. So the e is the exponential, base of 10. Okay, so for this one, I might want to scale by 3s to get to that 23. And 31 will be right on the cusp there. If you're writing these down in your chart, you can just round to the nearest tenth. So 31.6, -3 is 23.7. And really, just as a general rule, have at least 5 points on there. If you have more, that's fine. Okay, and then as we start to get down here into smaller numbers, maybe I would just write that at 5 I have 2.4. At 8 I'm at 1, so that's just going to help me. Okay, so I'm going to scale my y by 3s. So 3, 6, 9, 12, 15, 18, 21, 24, 27, 30. Okay, so if I scale by 3s, at -4, it's going to be like just right past my graph. So that's going to give me just a visual reference of where I'm going. And then at -3, I'm at 20, almost at 24. So I'm really close to this point here, so I'm just going to put my point close to that 24. At -2, I'm at 17.8. So again, that's really close to 18. Okay, it's an estimation, so I'm going to put it on the 18. At -1, I'm at 13, so that's going to be close to the 12, a little bit above it. At 0, I'm at 10, so if this is 9, 10 will be about there. At 1, I'm at 7.5, so about here. At 5, I'm at 2.4. Well, if this is 3, I have my 2.4 there. And 8, I'm at 1. Okay, make sure you're doing your graphs here in pencil. I know most of you do, but sometimes it might take you a couple times to get that curve where you want it. All right, how do yours look? Good. All right, and then the domain. Okay, look at your variable. X is not in the denominator, X is not under a root, so your domain is all real numbers. So I'm just going to let you write that, okay? That way you don't have to write it out 10 times. All right, what about our range? Do you guys know what your value of y is? Greater than 0. Nice. Oops, I forgot the y such that. So y such that y is greater than 0. So domain range, what's our y-intercept? Yep, and 0, 10 is on your chart. Remember, this is also your y-intercept for that one. So 0, 10 is how you write your y-intercept. Okay, and then the asymptote is the number that your graph is approaching. So when we looked at the table, they were getting closer and closer to what value? 0. So y equals 0. Okay, let's put that on there, and then we'll do the end behavior together. Okay, and then for the end behavior, this is something that we did first semester. For end behavior, you always have, as x goes to the left side, which is negative infinity, you have to tell me where the n goes. And on the right side, okay, you have to tell me where the n goes. So if we're looking at this left side, where is that going? Infinity. So f of x is going to infinity. Okay, now on the right side, it's getting closer and closer to what? 0. So you say f of x goes to 0. So that's a little bit different than what we did before. Before it was either infinity or negative infinity, but now it can get closer and closer to your asymptote. Okay, for b, your equation is f of x equals 3 to the power of 2x, and then you have this plus 1 here. So we're going to go ahead and we're going to put that into our graphing calculator. Let's see. So you have, let's clear it out. So you have 3 to the power of 2x plus 1. Okay, again, if you graph it, yeah, can you see how steep it is there? Okay. And then here's the y equals, in case you guys missed it. Make sure that the plus 1 that you have, that you arrow that down. If you have a calculator where when you do the caret button, it does the parentheses, you'll just put the 2x in parentheses. So close the parenthesis and then put the plus 1 there. And then let's check our table set. Okay, so it's at 0, so. Okay, so you can see these are going up very, very rapidly. All right, let's look what's happening on this side. Okay, it's going to 1. So instead of approaching 0 this time, it's going to approach 1. Okay, what do you guys think that means for our values? Yeah, so your asymptote is going to be 1. And guess what? Your domain, still all real numbers. Your range, we'll do in a minute. Same thing with y-intercept. Now, is there anything in the equation that could lead you to your asymptote? So if you have the plus 1, that's going to be your asymptote. See how there's nothing added here? That's why it's 0. Okay, so you could use that as well to help you. Okay? So we can go ahead and we can put in the 1. Okay, and then when we're doing our table, okay, I'm not going to 82 on this guy, so maybe the 110 would be my last value. So then 0, 2, negative 1 is 1.11. Negative 5, this says 1. Negative 10, this says 1. Okay? Now this is special because this value is so small that your calculator won't even calculate it. So if you were to plug in, like, see how this is 1? Okay, your calculator actually rounds this to 1. I'll prove that to you in a second. So when you're graphing this and you have your 110, which is here, and you have your 0, 2, at negative 1, you're really close, and then it says for these that you're on there. What you're going to do is you are just going to make this line follow your asymptote. Okay, and this is just a very steep exponential function. Okay, your range is going to be y such that, and it's still going to be y is greater than, not greater than, equal to. And this is why. Your calculator can only do so much, okay, with what's put in here. If you were doing some of this on a computer that had more calculating capabilities, it would be able to round this out, and it would still be really close to 1, but it wouldn't be exactly 1. So this is negative 10, right? If you were to plug in negative 10 for x, it would be 3 to the power of negative 20. You guys agree? Yes or no? You follow that part or no? Okay, so if you were to calculate that, see how it has e again? So really, if you added 1 to this, wouldn't it be, this is like 0.9 zeros and then 286. So really, when I add 1, wouldn't it be 1.000000286, blah, blah, blah? Okay, but because that number is so small, when you add the 1 to it, your calculator just rounds it when you add the 1. Okay, so that's why this is not equal to. It's still just greater than 1. Okay, and then your y-intercept in this case is 0, 2. Okay, so notice that you have an x with this and a plus 1. So that's not the same form as the one that we did on the front. That's why you can't just look at the first number there. All right, and then let's do the end behavior. So as x goes to the left side, what does the graph do? And as x goes to the right side, what does f of x do? So on the left side, it's getting closer and closer to what value? Yep. On this side, it's getting closer and closer to infinity. Okay, and then for C, For C, you have f of x equals negative 1/2, 3/8 to the power of x plus 2 plus 9. So let's make our table. What can you tell just by looking at the function? How about something that is one of the things we have to write down? Yeah, the asymptote's going to be 9. Good. And we also know the domain, right? Mm-hmm. If you want, you can just put this on your graph right away. Okay, so when you're plugging this into your y equals, if you want to, you can just make that negative 1/2, or you can do the parentheses. And then you have 3 to the 8th to the power of x plus 2. And then you have plus 9. So again, when you're making your table, you need to investigate what is happening. So when you go to your table and you're looking at these, right, you can see that the higher you go, the closer you're going to get to what value? 9. So these values aren't going to be as useful because they're all going towards 9. So we're going to want to look at some of these values here. Okay, so at negative 4, I'm at 5.4. At negative 3, 7.7. Negative 2, 8.5. Negative 1, 8.8. 0, 1. Anyway, this is almost to 9 there. And then 0 is your y-intercept. If it is one of the more complicated ones like this, I'm okay if you leave it as a decimal. But this is one of the more complicated ones you'll see. If it's an intercept, they're generally going to write it as a fraction. So if you're writing this as a fraction, you just have to plug in 0 for x. So if you're doing that, 3/8 to the second power. How do you do 3/8 to the second power? It'll just be 9 over, yep. Okay, and then you'll just multiply those together. So negative 9 over 2 times 64, 128, and then this will be just a large number because you have to do 9 times 128. Do you guys know how you can tell if the fraction reduces after you do this in your calculator? You guys want to learn something fun today? This what Bo Weary learns? Fun stuff. Oh, you guys were right. Okay, so if you just go to math and you go to fraction, it'll put it in the reduced fraction form, which is this guy. So again, this one is monstrous, and you are welcome to keep it as a decimal, but some of them are not going to be as large as that. And if they're not as large as this, generally the answer would be in an improper fraction. Once again, if it's that large, decimal is fine. Okay, so when you're graphing, you have negative 4, and then 5.4, negative 3, 7.7, negative 2 is 8.5, and then you're getting closer and closer to 9, okay? So what you're going to do is you're going to curve this part so it's going right along your asymptote. Do not cross it, okay? So you're going to curve this so it's going right along there. Put your arrow on, and then here, because these numbers are just getting very large, you can go ahead and draw the other end. Now, because this is underneath the asymptote, this is decay, right? Your range is going to look a little different. This is going to be y such that y is, yes, less than 9. And then do you guys think you could do the end behavior without me? I'll give you a little homework gift, the gift of not having to make your ASCIIs. And you won't fill it up. I just made it front and back, so don't get scared. Okay, so f of x on the left side is going where? Did you guys say infinity or something else? Negative infinity. So if it's going down, it's negative infinity. And as you go to the right, it's approaching 9. Okay, so some of the ones you're graphing and you have to find all of these for. Some of them you just have to do the graph in the table. And then some of them you just have to say, is it growth or decay? All right?